Hey everybody, today we'll be doing a video for our first learning target, which relates to functions and graphs, and more specifically, the definition of a function, the domain of a function, and the symmetry of functions. So our first question asks us to decide whether this equation here is a function of x and then give an explanation of why or why not. So there are two ways that we can look at this and solve it. The first would be recognizing that if we rewrite this as y squared plus x squared equals 4, that this is the equation for a circle. More specifically, a circle, it's not quite a circle, but close to a circle of radius 2, because the equation for a circle is x squared plus y squared equals r squared. So in this case, r would be 2. Now that's not necessarily essential to know right now, but it's good for future use, and I guess use for now, to know just generally what the equation for a circle looks like. And then knowing that this is a circle, we can decide that this is not a function. That's because it doesn't pass the vertical line test. It doesn't pass the vertical line test because if we drew like a vertical line like that or like that, we have two y values that are associated with the same x value. So now let's look at the second method for determining that it's not a function. This one's a little more analytical. It involves picking a value for x and then solving for y and seeing what happens. So let's let x be equal to 1, and now we'll plug in. So we have y squared equal to 4 minus 1 squared, which is just 1. So y squared will be equal to 3. Now the next step is to take the square root of both sides. And this leaves us with y is equal to plus or minus the square root of 3. It's very important to include that plus or minus here since we're taking the square root of y squared. Now it's this plus or minus that's really important for this question because that means when x is 1, y can be equal to both positive square root of 3 or negative square root of 3. And for that exact reason, it is not a function because it doesn't pass the vertical line test. Now let's look at the second part of this learning target, which relates to domain. So a lot of what we practice in class regarding domain involves denominators and involves square roots. And we have both of those here. We have a square root and we have a denominator. And we can tackle these independently for the moment. So let's go ahead and talk about the square root. If we have the square root of something, whatever is inside that square root has to be greater than or equal to 0, because we can't be taking a square root of a negative number. So now we can solve for this algebraically. The thing we have inside is x plus 4. We know that has to be greater than or equal to 0. So now we can say that x is greater than or equal to negative 4. And I'm going to start a little line chart over here, and I'm going to make a point at negative 4. And because it's a greater than or equal to sign, we can fill this in, which means negative 4 is included in that. We know that x must be greater than or equal to, so we can draw an arrow like that. It'll be greater than. This is x right here. So now we need to take a look at the denominator. We know that a denominator can be positive or it can be negative, but if it's equal to 0, we get a vertical asymptote, so a discontinuity, and that would not be in the domain. So we can set whatever we have equal to 0, and we're going to try to solve for x to see where that where this function is not in the domain. So more specifically, this would be a not equal to sign. So we can solve this out, x squared is not equal to 9. So if you take the square root of both sides, x is not equal to positive or negative 3. Once again, just like we did for part A, it's important to include that plus or minus sign. And then going over to our line chart, we have a point at negative 3 and a point at 3. And these are open circles here because our domain cannot exist at negative 3 and 3. Alrighty, now that we have all these points, it's time to write our domain out in interval notation, because that's very important. So, starting from left to right, get my little header tool out. When we're over here, we know that the domain does not exist until we get here to negative 4. So our first point will be negative 4, and then it will go to negative 3. And it's very important now to decide what sort of brackets we're going to be using. So negative 4, it's that closed circle, which means inclusive. So put a bracket there. Negative 3 is not inclusive. So it'll be a parenthesis. Now our union sign, and then parenthesis again, negative 3 to 3. Once again, it's an open circle, so parenthesis, union, parenthesis, 3, and then there's no other discontinuities right of that, so write infinity. Infinity is not a specific value, so once again we can put a parenthesis. And this is our answer right here in perfect interval notation. Finally, we're looking at a function and deciding if it is going to be even, odd, or neither. So it's before we even begin this, it's very important to know the rules of what's even and odd. So I'll write that down. So for a function to be even, we need to have it that f of x is equal to f of negative x. And then for an odd function, f of negative x is equal to negative f of x. So keeping that in mind, now we will find and simplify f of negative x and negative f of x, and we'll determine whether it's even, odd, or neither. So f of negative x basically means that for every value of x, we'll instead have a negative x. And it's very, very, very important, I cannot stress it enough, to use parentheses here when we're plugging in this negative x value. It makes a huge difference when it comes to the exponents, and you'll see why. So we'll plug in our negative x to the 4th power plus 2 over negative x to the 3rd power. Now, negative x to an even power with that parenthesis there, we can rewrite this just as x to the 4th because it's an even power, plus 2. But then in the denominator, a negative x cubed, it'd be negative x times negative x, which makes positive x squared, times another negative x, which brings it back to negative. So that's as simplified as we can get it right there. Now, negative f of x basically just means we're making the entire function as a whole negative. So we just need one negative sign, and then x to the 4th plus 2 over x to the 3. And we can assign this negative sign to either the numerator or denominator, but not both, or else it would cancel out. So let's just stick it on the denominator since there's only one term. Negative x cubed. So now that is simplified. Okay, now it's time to go back and look at our even and odd rules and make a decision. So, checking if it is even by using this, those do not look equal to me because of that negative sign right there. Now let's check if it's odd. Do f of negative x and negative f of x equal each other? Yes, they do. So that means this function here is odd. So I hope all of this makes sense. This is pretty in line with the solution key that you can find on Canvas. If you have any more questions regarding this, feel free to stop by office hours and we'll try to help you out. Thank you.